Anyway, I'm going to repeat what I just said. We have Ben Debow is going to be speaking from Fortified Data, and he's going to be talking about anything but troubleshooting when it's not SQL Server. So Ben, take it away.
No, thank you. And you guys want me to stand or sit? Doesn't matter.
It doesn't matter.
Okay. I'm going to wave to everyone at the camera. Before I get started, I'm going to see who we have in the audience. Like, are you background DBAs, developers?
Yeah, DBA here.
DBAs, and people on the phone, are you guys DBA, any developers?
DBA.
DBA? Okay. If there's any developers out there, I'll try to speak to that, but I'm going to focus on more from a database or DBA perspective. And one of the favorite things I'm going to talk about today is anything troubleshooting, but anything besides SQL Server. So many times when we're having different issues, we're impacted by what's up. Okay.
There we go.
Okay. We're impacted by anything that's up above us, down below us, or besides us. And I'm going to talk a little bit about what are some of the common different issues that we see out there, sort of how I go about looking for symptoms and different things that might help us have a better conversation with the other people that are in an organization that control those technologies and so forth. So my background is I've been consulting and data for about 25 years. I've been around the world, seen a lot of things, and one of the unique things that I did during COVID is I wrote a book, and the book is coming out in August. And it has sort of a unique title. It's called End of Abundance in Tech. Me and Ross were just talking about the old days, and back in the old days, we really focused on being efficient with our code and sort of what we used because we had to load mem high and do all this other stuff with technology. And I'm writing code today, and a lot of other people, they're focused on the functional, right? And one of the things is we've been using a lot of resources because every time there's an issue, what do? Add more mem, add more compute, add more storage. So I talk a little bit about some of those things. My focus and expertise is really scaling systems, performance tuning and optimization, and sort of designing what I call highly consolidated database environments. So that's where I sort of met Bill back in the day, and that's where I met Frank back in the day as well. So today we're going to cover a couple different things, and I do have a lot packed in here. I'm going to try to cover as much as I can. I think I got about 1 hour, and Ross just went about 5 minutes. I'll just hold up your hand. And one of the first things we're going to do is talk about rules of engagement, because as much as we want to, when there is an issue, to dive in, run into the building because it's on fire, we do want to pause and do a couple things before we dive into that issue. Then we're going to talk about some of the common issues that I've seen out there, and they're sort of in order of the relevance of how often I see these within the environment. And then we're going to sort of summarize this presentation and say, what do we want to focus on just long term? If there's any questions throughout here, just raise your hand. And Ross, if you want to watch to see if there's any hands raised on the virtual, that'd be great.
Yeah, I'm keeping an eye on the chat here.
Okay, perfect. So one of the first things is when you think about your environment today, our environments are only getting more complex. Number one is a lot of the systems we've been supporting have been up and running for 10 years, maybe 20 years, maybe 30 years now. So think about all this data that's in our platforms. One is there's probably a lot of old data in there if it hasn't been archived and life cycled out, right? Separate from that, we're going to the different service architectures, right? Instead of having the traditional 2-tier, 3-tier, we have all these different technologies that are surrounding this database container that we support within an organization. And our job is to make sure that's up, running, fast, and predictable, reliable, all these fancy words, right? So how do we do that in this complex ecosystem? Because you can see up here, we are one piece in the puzzle. So when things go awry, a lot of times what do people do? We're joking about this, but a lot of times people say, hey, it's the database fault, right? And it's almost like we're fighting against the IRS. We are guilty until proven innocent. And a lot of times If we have slow I/O, because we're seeing page I/O latch times and pending I/O times, etc., you have to prove that it is not our issue and down the stack. How do we have that conversation? And I don't think our world's going to get any more simple long term, but it goes back down to how do we better and more clearly identify the problem that we are seeing. So when we think about understanding, and a lot of times people say, I have an issue, and they're going to tell you this issue. What I ask you to do is repeat that back to them and say, is this what I'm hearing? Is this what your issue is? And a lot of times they also say it in a very generic term, right? A very wide, ambiguous statement. Narrow that down, right? At that point in time, you have a better problem statement, right? And we don't want to just drop RDP into a server and so forth and start. We also want to understand the impact. So if there is a fire, is it contained in a single room or is the whole house on fire? Let's understand that I used to be a firefighter, a volunteer firefighter, so you might hear some examples of that stuff in the presentation, but we want to understand the impact, right? So that we understand, okay, is this impacting every user or just one user? And is that user the CEO of the organization or is it, the call center, right? And at the end of the day is, what are some of the different things that, we see within that problem that are automatically going to eliminate certain things, but at the same time is we know we're already starting to say, I'm going to look at this, this, and this, and this. When we think about one of the most important things that I think we should focus on, we are data people, right? If we do not see data on that, it probably didn't happen. So, facts with supporting data. A lot of times when people are diagnosing problems, they're throwing things out there. You get on those critical outage calls, what do people do? I've seen this, I think I might this. I see this. Try to be the grounded person in there and say, hey, let's talk only if you have supporting data. Because one of the things that I see within root cause analysis events is that the root cause analysis is not tightly related to the incident, but people talk themselves into going, yeah, this caused this, right? Well, show me the data. And it is hard sometimes because you're not always going to have the data the first time that you have the issue. But if you don't have the supporting data, ask yourself, what's the data that you do need? Instrument that into the process so that the next time that happens, you have the data. Clearly define the problem, so I already said that one. This is important, the fundamentals. So when I was in college, I took data structures. I took statistics. I took all these different subjects, and it was very interesting. I found those very interesting, but they're very applicable to today. Understanding what a B tree is and why it's so important to understand what and how that works, right? Because that's also how a lot of the indexing or internal technology works. Yeah. That helps us eliminate things within this technology. Communication is also key as well. So we will have a certain amount of information. We want to understand not only what we need to say, but how we need to say it. So if I know I'm speaking with a storage person, they're going to have certain words that they use to talk about storage, right? So unfortunately, we sort of have to understand how do we communicate with storage admins. And we're going to talk a little bit about what those words are, like IO megabits per second, IOs per second, etc. But once we better understand, how do I speak with Frank versus Bill versus Charlotte versus Ross, because each of you own a different part of the stack, then I have a better conversation. Because a lot of times these issues, going back to the first image, are complex, right? Collaborate, engage with others, sort of what we just did in here. Everybody just helped me solve my issue because we all shared information within my environment. Anybody ever have CPU contention or CPU pressure that impacted the environment, right? I always say that this is becoming more of a challenge because as systems back in the day, number one is you had a lower amount of concurrency that you had to deal with. And what that translates to is you had a lower number of users executing a lower number of transactions per second. So the concurrency is the number of parallel things that I'm doing at once, not necessarily parallelism, but the number of requests coming in of me asking questions to do something on that SQL Server. Now, the challenging part is within Windows, right? What's the one CPU counter that you guys like to look at?
At the Windows level or is
At the Windows level, yeah.
I don't trust any of them.
That's a good one. So percent processor time. That's probably one of the, I call it the most famous counters in the world, right? It's in every monitoring tool, right? A lot of times everybody quotes it. If I open up my task manager right now, now you look in a CPU tab, it's going to show me percent processor time. Now, the challenge with that is a lot of technologies also say, well, that's how full the glass is. We look at it and go, oh, that's how busy the server is. If we say that's how maxed out the server is because the percent processor time is 90%, we're looking at one count. And one of the things though is SQL Server and Oracle and all these other platforms are MPP platforms, right? And when you think about what that really means is I could process many things all concurrently. Well, how do these SQL servers, because they've grown over time, they have a higher number of users, higher number of transactions, a larger amount of data, and that code, whether or not it's efficient or not, is executing. That code needs a lot of CPU cycles to be able to process.
Yeah.
So one of the things that you're going to see, and I'll show you in a little bit, but at the end of the day, a lot of these systems are at 25, 35, maybe 45% processor time, and we actually think that we have 50%, 60% extra capacity. We don't. And I'll show you where we should be checking and how. So I'll tell you a story about, like, in an Amazon environment, the Amazon's largest server, or used to be the largest, the X1E32. The more cores that you have, the less instructions it could process at a single point in time. So the 128 vCPUs can only process 4 things per vCPU at a time, right? So when a large client was at 30%, if they ticked up about 35% to 38 or so percent, they actually started queuing inside a SQL Server on the schedulers, and you can see it in there. But if anybody's looking at a generic monitoring tool, they would think they were fine, right? So the way we want to look at it is schedulers, runnable requests. And that's where this DMV, it's the OS pending, the OS scheduler task. It's going to be one of our DMVs that we love to look at. So this, on the top right-hand side, over here, this is the code. And I can always send you the code after this session, or I can give it to Ross and you can post it out there, right?
Yeah.
And this is sort of the formula that I use to help interpret whether or not we have compute pressure within SQL. Now, on the bottom, there's 2 different servers. Each of those servers has a different type of processor. So if you have your machine out right now, something that's sort of interesting, and you go right here, go to Task Manager, right? And if you go to Performance, and you're going into here, up here, you can see the processor type. Couple things to take a look at. Right now, we're gonna just look at the 3 gigahertz, right? Later on, we're gonna look at that 1185 G7. We're actually gonna look that up and say, hey, what can we actually process? But that is something that directly helps determine roughly how many current tasks I could execute within a SQL Server. Yes.
Now, I don't know if it's an appropriate time to ask this or not.
Correct.
At least in our shop, I mean, we're all virtual.
Correct.
Now, yes, I know somewhere there's a bare wire
Correct.
running all this,
Yes.
but that's so far removed from this,
Yes.
or at least I think it is, that I just wonder if the type of hardware it's on is even relevant.
It is, 100%. And there's a trick too. So if we go into an environment and we see that there's schedule pressure, because I'll look at this runnable task. If a client has runnable right here, and a larger, more than 10% of the schedulers are runnable, like, hey, you're in yellow state. We either Is there a question? Okay. So if there's a higher number and we say we need to have more power and you are virtualized, whether it's Hyper-V, VMware, doesn't matter. One of the things, a lot of the organizations have upgraded their hardware over time. And they'll have different types of hardware. They might have some UCS Gen 1s and Gen 2s in there, right? So one trick in there is to go, hey, VMware admin, what type of host is this running on? Because they'll tell you, right? And you're gonna tell you like it's a 3 gig, 2.3, 2.1, whatever. And in a couple slides, I'll show you, you could go in and look up that score. If they have a higher processor than one of those other sheets, you might be able to solve your problem by just demotioning it over there or live migrate. And all of a sudden, that current task count has a higher number that it can go up to and process per schedule. No other changes. So that's where just virtualization is sort of good because you could just say, move over here, move to this cluster, move to this node, if you have different node types in there or hardware. Okay. It's a good question.
Yeah, and then you got the admin that says, well, if I let you do that, then I gotta let everybody do that.
Yeah, but how many MVP platforms do they have in there that actually care about latency? Not many. I mean, so that's where the database products that are in there are sort of unique. I always say the VMware environments or the Hyper-V environments have to be designed for what I call data intensive workloads, right? And that's a whole different presentation. So up here, one of the things that we also want to make sure is that we're licensed correctly. So if we have pressure, one of the first things I do is make sure we're licensed correctly. We were literally in a client the other day where they said, hey, we got a SharePoint issue. I said, great. Well, let's just peek at, well, SharePoint uses SQL. So we quickly peek, and we have one piece of code, one file that basically runs 4 statements. I'll show you those statements in a second. But the number 3 result set in there, it showed 4 schedulers, right? It basically showed something like this. See the first red right here? These are runnable, right? And those are some high numbers. If you ever just see 1 and 2 there, it's not too bad. But again, this is 8, 9, 13, and 11. Those are queries that have memory locks and everything. They're assigned to the scheduler and they're in pending state. What do you notice below those? Zeros, okay? What do you notice to the left? The current task count is 18, 17, 16, 17. Below there, 0. Basically, very low numbers. They weren't licensed correctly. And it wasn't necessarily licensing. So Ross, you just brought up virtualization. One of the things that VMware admins do in Hyper-V, they'll go in and go, hey, sockets cores. Well, how do you guys license standard edition SQL? There's limits on sockets. Yeah. So if I configure my VMware incorrectly and have 10 sockets, I'm going to be limited on the number of cores to the first 2 sockets that I use, and then SQL Server restricts that down.
Not to mention Numa starts to freak out that it sees.
Oh yeah, I might have 10 Numa nodes too, depending on how it's presenting from the hypervisor up to SQL, right? So there's memory potential issues, there's Numa boundary issues, there's license. So we didn't change the SKU on this. We swapped the socket to core. We went to 1 socket by 10 cores because that kept it in a single physical Numa node. And guess what? SharePoint had no more issues anymore. Why? Because they were using all 10 vCPUs and that was right sized for that environment. It's those little things that are sort of hidden from us, especially in a lot of these monitoring tools, but we need to be aware of. Because the monitoring tools out there, they actually have one and said, oh, it says we're licensed for 10. You're not licensed for 10. You're licensed for 10, but you're not using 10 because of the restriction. Have you guys have probably, or how many of you guys have heard of high performance mode? A couple of you guys, okay. What high performance is, these are a couple settings. Again, I'm going a little bit lower, but these are all things that impact. If you're running a production environment and want to have predictable or high performance, we need to be aware of these, right? And this is also where you can create one sort of checklist and hand it to your infrastructure. You can say, any server that you give us for SQL or Oracle or any database platform needs to have this enabled for production, right? And this just goes back down to your base configuration for your database environment. So high performance is something that can be set in the BIOS, in the hypervisor, or an operating system. And a lot of times it might be set in one or multiple places. But inside of SQL, what we want to be able to do is make sure it is set. So in here, see this percentage of processor frequency down here? Right here?
Okay, yeah.
Yep. So one of the key things though is if you see over here, see on this CPU, it's basically 2,000 or 2 million. It's 2,000. That's 2 gigahertz. The other three to the right of that, it's 60%. So right here, right? This number right here, that's the percent of frequency. You're only running 60%. So if you guys all have a Ferrari, how fast do you want to drive it? You want to put a governor on the Ferrari and only be able to drive it 60% or 60 miles per hour? Probably not. You want to drive that as fast as you can. You're running production workload, you want to run that as fast as you can. That's high performance. There's a difference between high performance and C states. C states are basically a state in which the processor is, and this all impacts your throughput. So by disabling C states, especially on higher performance workloads, you can gain several percentage points just by setting that on or off. So what I say is for production workloads, disable C2 and C3. Guess what? Azure and certain compute optimized already has C2 and C3 disabled by default. Why? It's their best practice. I don't know if you guys ever noticed that. Other ones, it will be enabled. You'll see C2 types and C3 types. I say if you are scaling a system, if you guys have systems that process 10,000, 20,000 or higher numbers, I don't know if any of you guys do, disable all C states. This is perfmon, and I'll show you exactly how to do it, but what I like to do is just go in this is basically the report view. Just use these counters, right? And you can quickly go, hey, am I sitting at 100 all the time? And also, do I see any C2 or C3 types? If you see those in any of your servers, simple conversation with your infrastructure person, and they should be able to make that change. Yes.
Feel free to table this question if you want.
Yes.
Well, what is a C2 or C3 state?
Okay.
Like, maybe that's outside the scope
Yeah.
of this, and that's fine.
I'm going to give a baseball analogy.
Right.
And when you think about a person going into the batter's box, right? So basically C state's disabled. I'm in the batter's box, I'm all up, ready, the bat's all ready, the pitcher's pitching. I'm all ready, I'm swinging. There's no preparation. I'm fast as I can, I'm all ready. Basically, that's C state's disabled. And when you think about what a C2 state is, I'm in the batter's box, but bat's on my shoulder, I'm not fully ready. Pitcher pitches, I have to get ready really fast. There's that slight delay. Processor is basically, it has certain things staged out of memory, and it has to get it into memory and then be able to process your request, okay? C3 is basically, I'm over here warming up, pitcher's like, I'm ready to go. I have to run over to the batter's box, get the bat ready, and then be able to swing. That's C3 state.
Is this all power saving? Is that why it exists, power savings?
Similar to that,
Okay.
yes, yeah.
Ben, do you know if the VM host is set to high performance,
Yes.
but the VMs themselves are set to balanced or whatever it is?
It depends on, because I've seen them both where it's VMware is set to like high performance because you set that there, but then the OS is set to balanced. I'll see different things depending on the OS version.
Oh,
So
okay.
I still like to be able, at the end of the day, I can just check this. And then if I see this not set correctly, I can easily change it in the OS.
Okay.
If the OS doesn't enforce it, I'm setting it within the hypervisor.
Yeah, I've almost always seen it software related. So Windows, it doesn't care. It's doing the throttling.
Yes, because it's still managing the request. The OS is determining what and how am I going to process this request.
Yeah, I have always set it in the OS and the VMs, but then I've had pushback from a couple of VM guys who were like, well, it's set, on the physical machine. It's,
Show them that. If you
Yeah.
see this picture, that's your evidence
Okay.
per se, right? So one of the things that we talked about is like, instruction. How fast is the CPU, right? Close it over here because I'm gonna say something about licensing. So if you guys wanna reduce your licensing, the best thing you can do is go to this website when you buy your next vCPUs and interpret which vCPUs have the fastest, I call it processing ability. And you can buy a lot less of those because it's gonna turn around that request a lot faster than a 2 gigahertz box. So a 2 gigahertz box versus 3 in the right generation, I've gone down from 32 cores down to 8. That very large client that's running on the 128 core boxes, they said, hey, we want to keep on growing, but we want to reduce our licensing count because they had 8 of those boxes all across different regions and AZs and everything else, right? And that's a lot of licensing, right? So what we did some calculations. Guess what? 96 cores actually had 10 instructions per vCPU for a total of 960 versus the 128 times 4, which is like it's a 60% improvement. We downsized and got increased throughput by 60% and helped save, a large number of vCPUs. It's that type of math that we can do with this. So what I'm going to show you is this. So if you go to this website, basically it shows you lots of different things. And another little tidbit I'm not covering in here tonight, but it's important. If you are dealing with higher performance systems, the speed of the memory DIMMs is important, right? A lot of times you're not thinking about that. It's 1.6, right? Get the 2.3s, right? So the memory DIMMs are just as important as the speed of the processors. And that does, and that's the reason why we have NUMA nodes, because one's faster than the other, right? So in here, there's a couple things I want to highlight. Right over here, where we see this column right here, right? This is my CPU marker. This is how the fastest, the higher the number, the more it process, okay? But then you can also see the price. You're not always buying those top ones, right? But if your infrastructure admin goes, hey, I have a couple different types of servers. Hey, can I look at those? Put the numbers in there. See which number is bigger. Go, hey, I want the bigger number one. Okay. Number 2 is, I went in here and see, this is my box. So the way I did it, see, I put mine in there. So it would be interesting to see, you go into this website, type yours in. So mine has a score of 10,000, okay? What I did was, I went out to Azure, and I looked at both general purpose, and I also went to, so this is general purpose. So when you migrate to the Azure, it does matter what type of server you go to. The A series, the F series, the D series, or whatever. They will give you different miles per gallon. See, that's what it said. This is general purpose, 21,000. This is the D series, okay? 9,000 more, roughly. So these map into how many current tasks I can do inside a SQL Server. So that website is something I use very frequently if people are buying hardware, okay? So in here, there's a couple pictures. I'm not going to go over this just because we have a lot to cover. So now we're going to talk about virtualization. And virtualization is another area where we could get tripped up, right? Because as I just mentioned a little bit earlier, we're talking about, and this is all compute pressure, right? My SQL server is running a little bit slow. I don't know why there's pressure here. Well, this is something that we have to look at too. So up in the top right-hand side, right up here, this is the host that the virtual server is running on. So just like Ross said, it's like, how do I know what that's running on? In vCenter, one thing you could ask your admins is for read-only access. It's not going to hurt anything, right? And a lot of software also shows some of this host-based data into the tool. But you're wanting to look at this, and yet there, you can see the 2.9, and then that's down here. But down here, do you see that they have 2 sockets, cores per socket? But then I might be mapping in 18 sockets, 36 vCPUs, right? 18 NUMA nodes, because I can click on my task manager and see NUMA nodes. So as Jared says, we need to think about this because SQL does care about these things. So if I have an incorrect VMware configuration, it impacts my licensing. It could impact my NUMA nodes, right? And it could impact my performance. So we have a document, and we'll give this out as well. It lists all the things that we say you should set your virtual environment to at the VM guest level. That should be the template that the infrastructure team builds for that environment. Inside of there, we could have, just like we could have runnable or delays running processes inside of SQL within the OS, we could have it at the hypervisor level too. So there's two things that we need to focus on. You might have heard this before, something called CPU ready time. That's this right here. And the other one is co-stop time. So ready time is basically, I'm assigned to a vCPU, but I'm paused because the CPU is busy. Co-stop time is, I'm trying to assign it to a vCPU, but no, everybody's busy. Slight difference, but basically if you see either or, that means you have pressure. So what do you do? One of the best things is, and I give an open table analogy. You guys know or familiar with what open table is? Okay, so I'm gonna make a reservation. I'm making a reservation for all of us in there. And I'm gonna add 10 more, so I make a reservation for Rosebud for 20 people. If only 5 of us show up, they still have to honor that reservation. The other thing is in Windows, Windows doesn't, I call it seat everybody together / send all the requests over the first vCPU and fill that glass up until we're, it does it across all 20 vCPUs, even if it's little instructions. What the hypervisor does, it still has to honor each of those requests. So this is like an example of if you have a host that has co-stop time or ready time, first thing you do, if you're on with your admin and you're trying to explain this to them, because you've heard this conversation, sort by CPU count, this setting. Find the VMs that have very large, high vCPUs that are not using that much host CPU. So right down here, if you see this, these right here, I'd say vMotion is off. And the reason is because I have 32 vCPUs that aren't being used that much, but I have little pieces of requests going across all 30 vCPUs. Actually, it's 64 right there. That is putting overhead because your SQL Server is busy as anything over here, but it's competing against these VMs that are low utilization. Is the way Windows works, or any OS really. Okay. So all you do is vMotion is off, and your ready times will most likely go down.
Like having extra baseball players on the field you don't need, right?
Yes. Yeah. And it basically,
I would use the hockey, I would use the ice hockey
analogy.
analogy.
And you still gotta, make sure they have Avion water and all this other stuff.
Right, yeah, yes. And a pedicure, yes.
Yeah. So I'm gonna talk about Frank's favorite subject.
Oh my God.
Oh.
So, I will not keep this up on the screen. I love her fun. So, this image sells for only $5,000. It's Perfmon art. But I'm going to show you just really quick sort of how I use this, because some of the images I already showed you sort of key off of this. We have a base template that we use anytime. It's 5 minutes, 7-day capture. It helps with baseline systems. And that will be in the package if you guys want that. We use that for troubleshooting, capacity planning, trending, and just understanding the workload. One thing that I want to highlight is this. Every time you see one of these areas where it's very, let's see where's my mouse, where it's like this, where it's very, I'm dragging this thing all the way down so that you can sort of see this, where it's very noisy, right? I call it workload friction. Technically, we do not want to schedule inside of those times. Like if you're running processes and you can schedule a SQL Server job, don't schedule into those times. But you say, well, how do we know when those times are? The other tools don't really tell us. We have some technology that does. At the same time, what we want to be able to do is start to understand those times and even those out so that it's nice, more normal curve, more balanced workloads. Okay. So this view is great to be able to say, hey, time series, when are times busy? The first thing I do is I get out of that and I go to report view. So right up here, I go to report view. And the reason why I love report view, I go here first, is because I can see all the numbers. A lot of times I'm knowing thresholds, and I can say, hey, you know, it is, so if I'm looking at vCPU, do I have C2 time? Yep, I have C2 time, okay. What's my processor look like? Oh, 66%. This view is very easy for us to do that. Now, one of the next things we do, we always want to make sure we understand what we're looking at. So number one is we are looking at max. A lot of times I'm looking at max. I want to see the most things that someone said: transactions, batches, I/O latency times, network bytes per second, disk bytes per second, etc. Second thing we want to do, how much time? So this was 5 days. Because if I have a really small amount of time, it's not as accurate. This is 5 days sample, pretty good sample, okay? And then what we're doing is going through here and sort of taking a look at this. And a lot of times I go through and I'll delete things once I see that they're helping, okay? And then if I want to look at things over time, I go back to the report view and I'll go back here, but not that view. But this view is very tough to look at. I can sort of look at it, but the first thing I'll do is I go down here, and you could actually right click and you could unselect them all. Okay, so I can basically hide a counter to it. Okay, so I'm going to get out of here because, and if you do want to learn more about Firstmon, just shoot me an email. I can always go over it in like 15 minutes with you guys. Storage latency. So first thing was CPU, storage latency. How many have had systems where they have slow performance around storage, right? And what were some of the reasons why you guys had slow performance? What did they tell you?
Who's they?
The storage admin, the network.
No, the array's fine.
Huh?
The array looks fine.
Yeah, the array looks fine, right?
Yeah.
Everything's 1 millisecond, right?
Yeah, it's the database.
It's the database, right? I don't know why you're even seeing those numbers. I think Microsoft's lying to me.
Mm-hmm.
Yeah.
Something's wrong with Pokemon.
I know.
Or your SQL, something's wrong with your SQL query.
I know. Yeah, you're making my eye slow. What was your reason? What did you say?
The query.
The query, yeah, I know. It's tough. So again, we have to be able to capture the right information to be able to tell a story. So a lot of times the processes are running slower. We're seeing waits. The great thing with SQL, what's my runtime equal? Right? Or my execution time equals my runtime plus my wait time. They equal my execution time. So if I'm not running, I'm waiting. So if we're seeing high I/O waits and the wait stats columns. Another DMV I love is the I/O pending I/O request. That will show you I/O, outstanding I/O requests that it's waiting on. It'll actually show you network I/O. It'll actually show you outstanding network requests too, if you have really bad network latency. I've only seen that like about 2 times in my life, but I know it goes in there. So, and in Perfmon, if we were going into Perfmon and we go into this counts, if we go back in right in here, and we go to that report view, go all the way up here. Whoa. So these 2 columns right here, there and there, that's read and write time. So if I see those be very high, like those are 726. That is very high. So that is the last one. So now that we have slow I/O, what do? So these are different views that you can see. So if I see exec requests and I see a lot of I/O waits, that's over here. And the great thing within SQL Server, there's lots of areas that show us that we might be having a problem within my database platform. The other one is the I/O pending I/O requests. Those are pending milliseconds. And then we translate them to seconds, etc. And then we go have a conversation that says, I need this I/O in this amount of time. How many of you guys have an SLA for I/O with your infrastructure team? Or do you guys know if you guys do? And what an SLA is, a service level agreement. I might even call it a performance level agreement. So, if you look at cloud providers, Azure has an SLA for I/O response times. Google does not. Google only says that you can have 120,000 on their basically premium disk, but they won't tell you how fast that I/O response time will get there. So that's something to watch out for. Have you guys ever set IO affinity or CPU affinity? Okay.
I've never messed with it. Turned it off.
Yeah.
I'd say don't play with this. You know, it's one of those features where, you know, someone put it into the product and like, this would be a cool thing. I could sort of control, you know, my, you know, pistons and whatever, and it's like, okay. So one of the challenging things is, if I'm seeing high IO response time, and this is a true story, client said, hey, I'm seeing lots of slow performance. Number one is they had multiple instances on the server, right? So that already confuses things because I'm competing against compute. I can set my maximum, so I can sort of carve up mem, but I can't carve up compute. But it was odd because I'm like, okay, so why am I seeing this picture right here? The first vCPU in the box is not doing anything. The other three are doing a lot, right? Or then the first one's fully pegged. So there's a line up here. Yeah. Right. It's hard to see, but it's there.
Oh, yeah.
So the first one's saturated, the other three are. I'm like, oh, this is odd. Because Windows balances. Windows used to do the network traffic on vCPU one, or CPU number one and do all this other. It's gotten better on where it'll actually leverage more. But at the same time is, why are we doing this? So we went into the affinity and we're like, wait a minute. They had said, well, I only want to use CPUs 1 and 2. I don't want to use 3. And then I want to use the IO affinity. But then their config values, they never applied it and restarted the server. So their run values were different than config values. So don't play with this, but you have to be aware. It's like one of those things with licensing. You don't see it, but it can be impacting you, right? So if you manage your environment, you build your server, probably don't have to worry about that. When you are dealing with storage, as I mentioned, a lot of times you are having to prove that it is not SQL Server's issue. One of the best things we do is we more or less, we can show them the virtual IO stats out of SQL and show that it's slow IO. Storage people really don't believe that, right? They think SQL is doing some voodoo magic and they don't believe it. We sort of need a monitoring tool that will show IO response times and or else perfmon. I always just use perfmon. It's free, simple to collect. I say, here's my IO response times. I need to be here. Go find out where it's at in the stack. There's going to be two ways to measure it: megabits throughput or IOs. Megs is sort of like how much payload am I going to give you, and IOs is more about number of requests. And I talked about the PLA. Have an agreement. So as more organizations are going to what I call, service-oriented, like I'm creating a data service for my organization, creating infrastructure as a service for my organization, they should have SLAs, right? So if I have an SLA for my service, and I can get the infrastructure team to sign up that for how fast is it they can build a server, let alone give me storage, I have something to hold in front of their face that you're not meeting this SLA, I need to meet the SLA. Something else that's sort of changed, we can have a technical conversation if you want to, but how I allocate disk. A lot of these storage arrays, because I used to do the disk where you'd have different count of drives, 15Ks, 10Ks, I could do 125 IOs per second, sequential, random, benchmark them, etc. All these solid states are doing 20 or 30,000 IOs, and that's for one disk. And all these storage arrays like Pure and Tintry and all these other ones are basically one big pool. So even if us as DBAs think about logical containers like I need a data drive, I need a log drive, I need some DB, I need a backup, and I need another data drive. We really don't need that anymore unless you love, separate drawers for each one of your pieces of clothes. Another challenging thing is the more drives you have, the more you have to manage. So if you have 100 servers and you have 4 drives, 8 drives, that's 800 drives you have to worry about 20% free or 10% free, right? When you get in the cloud, you only need 1 drive. Technically, you need 2. Ephemeral storage for MTB, put everything else on the other drive. Now, Blob Store will be able to keep up with your IOPS, which is the first one, because they have an SLA against it. So you only need 1 drive in the future, or even now, if you're on solid state or cloud. Just size it correctly for I call it, to meet the SLA for what you need. How do you see what your SQL Server needs? The way you do it is go right in here, okay? There's two methods. If you are looking up a megabit throughput, that number right there, disk bytes per second, that's actually a very big number. It's 2.2 gigabytes per second. These guys are actually saturating a network interface card. That's why they have that high I/O time, okay? If you are in the cloud, where my mouse go? I'll do it this way. There's just reads per second and there's writes per second. Those are your I/Os per second. Add those together, so it's 12,000 plus 2,000 plus some change. It's almost 15,000 I/Os per second that I'll need. And when you go into Azure and you're allocating blob store, certain ones like the general purpose is 500 I/Os per second, you have to stack a whole bunch of those together to equal 15,000. The premium is a lot higher. Stack those together, allocate the storage, and you're good. That's your capacity planning exercise.
So let me,
Yes.
so you're saying we don't need to carve up disks anymore?
It's one big pool behind the storage. And on the storage array, it's one big pool. And that pool can provide a certain amount of I/Os per second at a certain amount of latency, right?
Assuming you're on all flash.
Assuming you're on all flash. If you're on
Drive it away.
15K, they still will pull that out, but at the same time, though, is just say, I need a disk. Can you give me a disk that will meet 5,000 I/Os per second at 5 milliseconds or below? If they say yes, go, okay, put it in writing, give me a drive. And then you're good, because this will keep your administration time down too if you're managing large environments. You might be saying, okay, well, what about tempdb and data, or log and data? Again, what's your SLA for transaction log, right? You know, if I ask everybody in here, it's going to be slightly different numbers. Well, let's just say that nothing in your environment is insane high volume. You might go, okay, 5 milliseconds or less. I'm good with it, okay? But if your transaction logs, you're doing large ETL and everything else, you do have some tight windows and you're tweaking some data, and I think your environment's pretty large, maybe. You might say, well, I do need a little bit better latency than 5 milliseconds. So give me this drive at 5, give me this drive at 2. But it's all off the same storage array, right? So that's where I always say, one drive satisfies, but give them their least common denominator, which I'd say 5,000 IOPS at 2 milliseconds if you want your T-log to meet that too. Does that answer your question, or?
Well, it does. It's just, I'm having a hard time wrapping my brain around that.
Yeah, and that's where it has changed. We're ingrained, and I don't know, we could ask, well, how many drives we allocate? It's tough, but I've seen it because, when I go into these cloud environments where they're pushing insane amounts of volume, like 10 gigabytes of traffic and everything else, it's one drive. Put the tempdb on ephemeral storage, because that's all SSD local attached in the cloud. Not every server in the cloud has ephemeral. But as we're running databases, a lot of the servers we pick will have ephemeral, which is basically like a local transient data store. And we could talk about that maybe afterward too.
Sure,
A little bit more depth. And it also, guess what, impacts your cost, right? So do I want to manage 8 drives times 60 servers, 20% free on each of those drives? Or do I want to manage, across 60 servers, or do I want to manage 60 drives with 20%? And it goes back down to, it saves us some time, it potentially saves us some money. For not a problem, tier those down. Guess what? How many of your development environments actually have a performance SLA? No, you're testing for functional. Size them for functional testing, right? Only when I push up to UAT do I need to potentially be able to perform. Sort of showed you the I/O planning needs already. These are in here. I'll just glance through these, but I've been saying a little bit about this. So see that ultra disk right here? 160,000 IOs per second, right? these are the things that you, and the link's right below. So when how many are in the cloud today? Couple, okay.
Yeah, we're going there. but
Okay,
We're also gonna be on-prem.
okay. So when you go there, this is an important URL, and then the other one too, where you're looking at the type of processor, looking at the type of storage, okay? And this also just shows you, see latency SLA, single digit millisecond. And this is the important detail you need to look at, not all these other big numbers. And we look at GCP. So GCP doesn't have a performance SLA. It doesn't say, I'm gonna guarantee you single digit. And they give you double digit. Sometimes they give you triple digit. A lot of people are migrating there, and they're migrating critical workloads that need single digit. It's not a good situation. I'll help you guys. So network, okay, so we talked about storage, talked about compute, network. Have you guys ever had any issues with network?
Never. Never seen it.
Yeah. So what type of issue have you seen with networks? More like, I call bandwidth related, latency, drop packet related,
Mostly, latency.
latency, okay, yep.
Yeah, and then, of course, if we're talking about things like availability groups,
Yeah.
that's those packet drops.
Yes, yeah. So when you think about why we care about it, if you guys are supporting AGs, mirroring, transrepl, any of this other stuff, things that I need to get something from here to there, commit it, round trip back, do an act back, latency is an important one. If I'm doing large transfers, et cetera, between app servers, I probably care about bandwidth. The ones where I care about bandwidth more so are people that are using network cards and setting them up to transfer storage blocks, right? Because I could have a big storage array back here, goes across the network cards. And then that's where I can saturate this. So then it's a bandwidth play. That 2.2 gigabytes that you saw, 700 and some milliseconds of latency, that's because they're saturating their network card. It's very hard to see because it's in a virtual environment, shared network cards. So it's one VM on there, but you saw high latency in the operating system. So what we had to do is go, well, we see high latency even when we're not asking it to do much. That basically says, okay, is it a shared infrastructure issue? And then at the same time as we said, well, wait a minute, we are pushing a lot. What size cards do you have in there? That's why I put up there 1 gigabit and 10 gigabit. That's what it translates into as far as how much I can send at any point in time. Because if you're in the, again, perf mon, and you see high latency, you're like, okay, which one is it? I need to tell my storage guy and a little bit of what I see. You're gonna go, okay, I see high latency time. How much am I sending? I'm gonna go look at the bytes total per second, and I'm gonna do quick math. You can go to a calculator out there. I just basically 1024 it out, and then this is basically 148 megabytes per second. I go, okay, is that less than that? Hey, we're good, okay? The other consideration that Jared mentioned was ping times. So if I have AGs in place and it's across a WAN link and I'm trying to do synchronous, I need to be very, 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 very careful in my TTL, because if I don't have that response time, and I call 30 milliseconds or less, my AG implementation with sync is not gonna be that good. I'm gonna see a whole bunch of header sync commit waits within my wait stats within my exec requests. So that's where, you can do a simple ping and see that. But this is all getting into, do I have network saturation, right? Or do I have network latency issues? So how often do you guys ever ping a server just to say, hey, what's my round trip time? Probably not that often. If you have a high performance system and you do care about, you have AGs, you have app traffic, and you're saying, hey, make this server faster, make sure it's really fast. And you set the BIOS, you did all these nice VMware configs. Another thing is to run a trace route. So you go in here and run a trace out, put in the thing. It tracks all the hops and all the back. It goes, well, am I taking one stop to get there? Or am I going all the way up Michigan and all the way back to be able to do that? And that's another like fun trick that you can apply. My definition of fun is different. So replication is another thing that, you know, we all encounter too. So how many people have replication in place, whether it's transpubs, Golden Gate, something like that, right? A lot of times we're trying to ship data to somewhere. So one of the things that we have to be aware of, one is it does impact network. We're transferring a lot of data back. But why I have this here is I've seen more issues around more of the data type matching, right? So if I have like a Golden Gate in place, so you can take data from Oracle and put it into SQL, right? I've seen some configurations where the replication tool is not set up correctly. And then what that does is it makes SQL Server do a whole bunch of data type conversions that look like this stuff. What happens when I start doing data type conversions in my system? Are those free? No. No. These are costly.
Yeah.
And now these are using CPU cycles because I'm having to do a conversion, and these were dates. So I got a 6/22/2022 date and pushed into a varchar max, right? These are the things that, again, if I'm seeing high compute times, I'm running replication, I go, why is this statement? And notice over here, why did I find this? We all have this code. You know, Glenn Berry has the scripts, great scripts, right? All those DMV scripts that we run. What's my top worker time in my system? What commands? I'm like, whoa, these worker time, right in here. You can do this. These times, very big numbers, right?
Wow.
Actually, let me do this. 1, 2, 3. Okay. So 439 billion. Okay. Now let's have more fun. What are these statements? Oh, delete statements. So very simple statements, or it's even better down here. Insert into, and these were just value clauses. Why were value clauses? Insert into table. Value clause, no sub select, no triggers either, Frank. You didn't have any triggers in this system. So, why are they taking this much worker time? I said, let's go find out. Go look at the execution plan. We're doing conversions. So, we should never see DML as the top.
Doing conversions, data.
Oh,
The implicits and stuff like that, because all the data type stuff, and then it's forcing SQL to do all this extra work to be able to put the data in there, right? But it's those things that, because you can see that right there, convert implicit, but it's these things that were impacting our performance, and that worker time was impacting all this, because this was a reporting server. For the DML, the process of replication is consuming the majority of the compute time, and all of a sudden the reports from SSRS couldn't really perform as well, because you had a limited amount of resources. And the last thing that we want to focus on that I see is, what do you have running on your server? A lot of people go next. Some people love shared servers, which is fine, but you better be an expert at cutting pizzas. And I better know exactly how much pizza everybody's going to eat. And I only have one pizza to cut up pizza slices. That's why it's tough. Because if I was to guess, this is a perfect round table in here. And if I want to try to guess on how much you want to eat for pizza tonight, and I want to cut each piece up, that's like what I have to do for maximum inside of SQL. And technically, I'm trying to figure out, well, which servers are going to use how much compute, how many VCPUs do I need for each one? Oh, by the way, at what time? Because I might have a whole bunch or end up stacking and have compute pressure at certain times. Virtualization is a blessing. Same with the cloud. Right size all those servers down, one instance, one version of SQL, or one VM, one version of SQL. Manage it. You could have one VC box, right? That's fine, right? technically you're gonna have 4 licenses for that unless you're on enterprise, but that's a different subject. Understand what third-party products. So one other important point. Very beginning, we looked at processor time. I mentioned processor time. Okay, I'm gonna show you one other counter that's important. Okay, privilege time. Do you guys know what privilege time is?
I don't remember.
So it's basically kernel time. Basically, I think about who manages outstanding IO requests, who manages my network requests. That's privilege time. Okay, so I've seen times, and see this right here, 27%. That's 27% of a 24 core box. 27%. It burst to. Why? So one of the things that causes that to go up, if you have a lot of storage latency, I have a whole bunch of outstanding IO requests that I already sent all my requests off to Jared. Jared's out to lunch, he's a little bit slower. I gotta hold all those requests open and more IO requests are coming in. I'm waiting for him to get me my answers back. All that takes up CPU cycles, which is classified under privilege time. And I've seen privilege time jump up to like 60%, and the issue there was filter drivers. Virus scanning is filter drivers. There's some other products that are filter drivers. If you have, and virus scanners also have all these other features that they have in there, like also packet sniffer. Don't enable packet sniffing on a SQL Server. Still have your virus exclusions in there. If you see privilege time jump up a lot, check filter drivers. So, and there's many other issues for non-SQL, but I hit on the ones that I see a lot, Frank sees a lot, and so forth, right? One of the first things we want to make sure we do is define the problem that we're trying to solve, right? We always love to go help somebody, but sometimes we're helping solve the wrong thing because we didn't clarify what the problem was and ask a couple qualifying questions just to make sure that, Charlotte is seeing what I'm seeing. She might be, thinking and saying something else, and I'm sort of finishing her sentences at the same time as once I ask a question, I'm like, oh, it's really this environment, right? Or, something like that. We only want to deal with the facts, right? So when we're presenting something, have this data, right? If someone's telling you that somebody was mugged in this park over here, and I think it was Johnny or whoever, well, where's the evidence? Show me the evidence, right? Collaborate and communicate. We're all on the same team. And this is one of the biggest things is because most organizations, people are focused on their horizontal, and that's great because they're really good at that. But there's a conundrum in the corporations today. And the conundrum is this: infrastructure people speak vCPUs and MEM and storage. Developers and usually data people speak data and code. How many of us know the miles per gallon for a vCPU? And how many infrastructure people actually understand code? Infrastructure people ask the DBAs and the app dev people, what size server do you need? And we just tell them the biggest one we think of. And then all of a sudden we're oversized. Same time as when issues go on, they blame the code. Why? They don't understand the code. So we need to be able to collaborate and communicate so that we can talk a common language.
I found that it's been the DPAs that have been those collaborators.
We're an essential part because over time, I'm giving this talk today. Why? Because we have to be able to communicate out storage and compute and so forth, right? App dev is usually removed still. Because only one or two, they have 500 app dev people that created all this code, right?
Mm-hmm.
And they have a team of infrastructure. How many DBAs are in those organizations? Probably on one hand, unless it's a really large organization. So we are usually the facilitators. One is we're saying it's not the database, and maybe it is, right? But we are trying to bring these people together, communicate. The more you are better able to communicate within your organization, the more of a leader you're going to be, and the more effective you're going to be at troubleshooting and solving problems. And at the end of the day, too, there might already be SLAs that are in place, make sure people are meeting them, hold them accountable. If there are not SLAs, and you're creating data as a service, infrastructure as a service, right? Technology as a service. If you put as a service, I need to have SLAs and so forth, right? Because that's going to help everybody speak a common language.
Question for you.
Yes.
How far are the salespeople out on knowing all this? I mean, they have no clue about any of the stuff you're talking about? I mean, in a big organization, I mean, there's so much to learn, so much to know about.
Can you repeat the beginning here?
I'm just saying, you said the DBAs over here,
Yeah.
and these people over here. Where would the salesman be in that, like a salesperson be? I mean, are they they're like clear in the dugout or in the pitching box? I mean, where are those guys at in
Well,
terms
it's
of?
challenging because when you think about, the question is, for the salespeople and some of these other individuals, where are they at in this
Right.
story, right? Piece I left out, and this is actually important because as we go to the cloud, everything that we're doing is now being metered, right? It's the utility
Oh,
compute
sure,
model,
yeah.
right, into the cloud. And you think about CFOs, finance people are now having to understand more about why is technology, and they're asking this question, why is technology costing this much, right? And then infrastructure people don't know code, and they say, well, it's bad code. And then the dev people say, well, I don't know it costs this much, I've never seen the bill before, right? So we have all these business people trying to talk down to technology, and then the other issue is that we just talked about is infrastructure and app dev do not fully understand. So now we have this triangle where they all speak different languages. So, yeah.
I was just gonna say that.
Yeah, go
Yeah,
on.
in my previous organization, that was like the issue, like
Yeah.
the C-level folks did not understand like the infrastructure pieces.
Correct.
And that's like very.
But now they're getting a bill and they're sort of being forced to understand because as they go to the cloud, I'm getting things that are 2 or 3x. How do we better understand and present data? So one of the things, and this is not a sales thing, but at the same time, this thing speaks to what you're talking about, right? So CFOs, we need to speak a different language. Everybody in here, if I pulled out $1, everybody understands what that means. Before this conversation, if I pulled out an IO, can you all define what that means and the value of that? If I pulled out a CPU cycle, could we understand what that means? Probably not. That's the challenge out there. So we need to be able to bring better transparency, speak more of the business language, in my opinion.
Yeah.
And that's where I think we need to be merging down some other attributes. So when I promote code to production, right, we have been always looking back. I need to look forward. I need to understand what this code cost me over 1 year or 3 year. Day one today, I might represent it in CPU cycles. When I promote this code, well, what's the 1 year cost of this code? Because most code runs for 5, 10, 15, 20 years. Because I was just telling Ross at the beginning of this, there's a system that we're supporting for 20 years. And I go, hey, what about this? The top statements in there could have been 20% faster. And they're like, yeah, it probably could have. Think of how much money you would have saved over 20 years. A lot. So we need to start to think about how do we better communicate with others and what do we have to say so it resonates. The business is going to be more in our business versus less as people go to the cloud. And or else, guess what's happening? Dell and HP are now leasing servers and doing as a service model there. So now even on-prem in your data centers, you're getting charged more too.
And one of the things that I see, the cost is becoming, it's a catch-22 because you're seeing a much clearer cost of, let's say, a particular application. But oftentimes it's misunderstood because if you go out and say like, how much did this cost me before we went to the cloud?
Yeah.
Right? Well, the cost of the server was this, cost of my SQL license was this is the drives, this is how much it cost. Well, what about the guy that's monitoring your data center? What about the power consumption? What about the cooling? What about the fire suppression system, the emergency generator, right? And so you go in there and you might say, well, this is the cheaper server, this is the more expensive server, it's brand new.
Correct.
This one's 15 years old, how much power is it consuming? How much heat is it generating?
Yeah.
It's quite possible that this server right here is costing you more than this one. And all of that have been taken, like we didn't see that. But now in the cloud, they say, this is your SQL server.
Correct.
This is exactly how much it costs.
Yeah, I mean, because you have tagging and transparency, And what Jared sort of talked about is, no one understands the total cost of ownership for apps. So even in the cloud, it's a lot more transparent, but, where application vendors have a tough time, they built the app for the general purpose, and then you're the biggest client, and then they tell you to buy a next size server or whatever, and after 1 year, it's already out of capacity, and then you buy that, so your TCO of that app is actually inflating. But what we want to be able to do is, how do we better represent the total cost of ownership, whether it's an app level, the code level, or data, right? There's stuff up here that you can go read about some of this stuff. Some articles out here too. So see that bottom one? What is technology really costing them, right? Sort of what you just said. Why even your CFO may not know, right? So these are starting to help us better understand what we can do to better help our business understand, not only what we have today, but also how do we start to optimize our environment and start to change and make things better, more efficient. So hopefully you liked, what you heard. I'm around for questions. I could get you guys any code, and my contact information is here. So definitely thanks for having me as well.
Thanks,
Thanks,
Ben.
Ben.